Welcome, everyone, to our talk. Well, Urban Risk Index, the NYC Index for Urban Hazards talk. Unfortunately, my co-presenter got sick today, last minute, so I will be presenting alone here today for you. Don't worry, we are in good company. Actually, my supervisor Melissa, and my colleague Martha and Sarah is here. So if you have any question about, I think we covered it for NYSM. So by the way, I'm Te. I'm part of the resiliency and recovery planning team at NYSM. Next slide, please. Next slide, please. So yeah, here's a quick agenda. I'm gonna cover both a little bit about NYSM, so New York City Emergency Management, what we do as sort of agency in general for background. And I'm gonna talk a little bit about hazard mitigation plan, which is a big part of what we do as a resiliency planning team. And then I'm gonna get into the actual tool, the Urban Risk Index, in more details. But before I do this, actually I wanna sort of do a quick poll just around the room, if you can get a show of hands, how many here are you are in resiliency planning and emergency management professional? None. Okay. Oh, one. Yes. Sorry, what you do? Do you mind telling me?
I'm an NYC. I do research.
Oh, do research, emergency management research? Okay, cool. So we got one. Okay, so everyone else here is just open data in our open data community. I want to see a cool open data product. Okay, cool. Yeah. All right. Just to want to get a sense of the room real quick.
Sorry. So make sure your slides are being recorded.
Oh, okay, cool. Yeah, thank you so much. All right, next slide, please. Okay, New York City Emergency Management. Okay, so introduction for NYSM. New York City Emergency Management, where it helps New Yorker before, during, and after emergency through preparedness, education, and response. Next slide, please. And our agency is responsible for coordinating citywide emergency planning and response for all types and scales of emergency happening in the city. Next slide, please. And we're staffed by more than 200 dedicated professionals, emergency managers with very diverse backgrounds and expertise, and we also have professional detail to our agencies. For example, the fire department, police department, they have professional who detail to our agency and provide their expertise, helping us to do our job better. Next slide, please. So I'm going to talk a little bit about hazard mitigation plan here, which is really where the Urban Risk Index sprout from, and a lot of work that this is really at the center of all of the work we do. So next slide, please. What is hazard mitigation planning? So I kind of already go over this, but if you ever see a FEMA, that's the Federal Emergency Management Agency, they will show this circle at the middle, you talk about recovery, response, recovery, and mitigation. And I think that's really important for folks to understand emergency management work, because I think it's very intuitive for people to understand, if there is an emergency, let's say there's a big fire, we got to respond, and then we got to put out the fire. Well, we don't actually do, but then, we talk to the fire department folks and they put out the fire. And there's a recovery process where we also involve, we rebuild things, do recovery works with folks, have people housed, make sure people have funding for get their property damage back, for example, right? That's very intuitive for people to understand, but I get the sense that people sometimes ask then what do you do the rest of the time when there's not a big emergency? Well, we do a lot, because basically we will be doing the mitigation and preparedness part of this big cycle of things. And basically what we do is we identify natural disaster risks and vulnerabilities in neighborhood, in our environments, so that we can know what are threatening us, right? The hazard part of this. And how we do it is by develop a long-term strategy on how we might mitigate those risks in the long run, right? And why we do it is the last part, which is so that we can break the cycle of just having disaster damage and do risk construction every time. And as we all know, face climate challenges. And as times go on, you just see that we have worse and worse disaster. And how do we mitigate that so that we not every time we are sort of in the worst case scenario, right? That's the mitigation part of this. Next slide, please. So again, mitigation, the hazard mitigation plan, HMP, is an actual plan that you can find this document on the website that was linked earlier. And it is the big sort of three components of it is like hazard environment, which is social demographic factors that we have as a city that's in our environment. Understanding those can help us like what potentially can the social vulnerability can make a disaster worse in certain cases. That's what we try to understand. And hazard profiles, well, what are the hazards, right? Like when we talk about like an extreme heat event, what really is the consequences of that, and what does it even mean to have extreme heat events? So that's hazard profiles. And mitigation is like all the things that we do to, again, make it better. And that can be from, like coastal seawall projects where prevent flooding from coastal storms, or cooling centers, like in the city, help you to get away from the heat in the most extreme heat day in the city. Next slide, please. And we have a number of tools that help us do that. Obviously, today we're going to focus on the last urban risk index, but we also have hazard history consequences tool, where it's a comprehensive record of past events happened in the city. Computer risk assessment really help you get into the specific for a specific community or neighborhood, understand the profile, like social demographics, but also like past research done in the neighborhood. That's like a central location where everything is deposited. But we're going to focus on the last piece, urban risk index, today. Next slide, please. Yeah, next slide, please. So NYC urban risk index. So what is the urban risk index? It's a tool that assesses community risks associated with natural hazard in your city. And it aids emergency manager community by providing contextualized quantitative risk analysis, really focus on the quantitative part of this, because it's really hard, I think, for average person in the city to know what your hazards is, but also like have a sense like, what are my risks, right? Like I think about it a lot, like as a just average person living in the city, what is actually my risk when it comes to like say earthquake, right? Like how do I contextualize that and make sense of that? If I don't see like a generic newspaper article once in a while that you have this hazard happen in your community, for example. So I have to do that. Next slide, please. Yeah, and I guess like this is where, normally when I talk to a bunch of emergency managers, they will have a good sense of what all of those things are, right? Like there are a bunch of index basically around, like DOHMH have this heat vulnerability index, which talk about your heat risk in the city, or the pandemic vulnerability index that talks about like what pandemic disease risk you might have in certain neighborhoods. And the most comprehensive one, which our URI also model after, is the national risk index to the right. And I'm just gonna talk a little bit about like, if we have that national risk index, why do we still need an urban risk index? Next slide, please. So basically, so the national risk index, that's encompass like a suite of hazards. So it's multi-hazards, unlike the heat index or the pandemic index, but it's sort of done on a national level. So all the data that you pose and the methodology was based on a generic national model, right? Like if we think about like transportation accessibility, New York City just looks a lot different from an average city in the US. And also like the loss calculation done, which I'm gonna get into a little bit what exactly is loss calculation for hazards, but it's not tailored to New York City. Like we really want to localize that risk for the New York City residents so they can really understand what their risks are. And also hazard included, again, there's just things like just only specific to New York City that doesn't apply across the country, or there are hazards that are more common in the country but not really specific here to New York City. And also the tool is owned by us, by NYSM. What that means is like we own the complete methodology, and that's why we're presenting here today. We are making a big push to make everything open source. So it's already open source, but we're making I'll talk about how that's what's our plan for open source the tool. Next slide, please. So quickly, what's the hazards that currently cover in this what we're calling URI 2.1? Is 6 hazards. So coastal erosion, coastal storm break down to 2 hazards: high winds and flooding, winter weather, earthquake, and extreme heat. Next slide, please. So how do we exactly measure, again, quantitatively the risk? So it's actually a very simple formula that we're using here. So hazard impacts is the potential economic impacts associated with each hazard, multiplied by social vulnerability, which is the demographic factor that can increase the likelihood of experiencing harm. And the resilience capacity, that's a neighborhood or like community ability to respond and recover during after a hazard event. I want to hover on this one more second here, just to show you that we constructed this formula really to make it as intuitive as possible, while it's like representing the risk, because I think it's very natural, or like I find it pretty intuitive that the social vulnerability and resilience capacity are acting like 2 multiplication factors, the scaling up and down the hazard impacts. So like social vulnerability is higher, then your hazard impact is also scaling up higher. And the resilience capacity is the sort of mitigating or reducing your risk as higher the resilience capacity goes. So that's what I want to emphasize, why the formula is sort of set up this way. Next slide, please. So a little bit in the weeds about like what each component is. So the hazard impact actually are constructed with economic consequences times the likelihood. So that's the probabilistic events per year. And the economic consequences are mostly breakdown by 3 receptors: people, buildings, and land. And that is multiplied by the marginal loss per year. And basically that multiply the probabilistic events per year, that give you the whole economic consequences for, or the marginal economic consequences for that. And then later it's converted into a score that's as our final hazard impacts. And also want to highlight that, what do we mean by when we say like it's really customized to local environment, is that like if you probably can't really read it, but like here are some of the items for hazard impact. And for example, building damage have flood, wind, and earthquake. So it's really hazard specific and also like localized to what are the situation here in New York City. For them, I think we also have like tree services, which is a big part of emergency response here in the city as well. Next slide, please. And social vulnerability, on the other hand, is more generic. It's the CDC, Social Vulnerability Index value, and it's consists of those 4 components: socioeconomic status, household composition, disability, minority status and language, and housing type and transportation. That's just pretty standard for social vulnerability goals for this type of calculations. But we do get the New York City specific data. Like we get the best data available, for example, on like minority status or English proficiency. Those are like more localized data. We work with city agency partners or from open data that we get this data into our tool as well. Next slide, please. So resilient capacity, again, like the hazard impact, is highly customized to hazard. So those 4 components: community capital, mitigation landscape, response capacity, and recovery resources, are dependent on which hazard you're talking about. The calculations are all different. So that sort of speaks to the complexity of the tool, which I will get into a little bit. That's the challenge that we face. Like for example, like flood insurance coverage would be only apply to flood risk, and that will not play a factor in other risks. And how to manage that as a tool in our calculation is sort of a main challenge of this tool. Next slide, please. So some potential uses quickly, and we're still in the sort of mitigation planning world, what we do as a NYSM as an agency and we as a team. That is like provide methodological and quantitative risk assessment hazard profile. Next slide, please. Oh, sorry. we're just going to go through those quickly. And we do grant applications with those risk assessment. And we do, next slide, please, decision making and prioritization in our operations and response planning. And last piece here is sort of a more education piece. Like we do want communities, like each member of New York City, to understand their own risks, and hopefully like this shed some lights on that, like how you will assess your own risk and how do you prepare for potential hazard events. Next slide, please. Okay, great. So since we're Open Data Week, we'll talk actually about a little bit of the development of this. So the tool is completely built with Python. That's a very intentional decision the team made at the time that we sort of put out RFP for this tool, that we wanted to be able to maintain it in-house and with just open source knowledge. So the tool, as right now, is still completely open source. It's all built in Python. We're trying to make a push on putting out the results into the world. So we're trying to make a push to publish some of our results in open data. Also we have an S3 platform, which you can find a link to in the GitHub repo, etc., that will showcase you not only the risk profiles for different hazards, but also like each subcomponents I just go through. So you can really look at the neighborhood level and see, oh, for example, what's my response capacity for a winter hazard, for example. So like you can really get into the weeds on like your hazard in your neighborhood, what's the level for each one of those subcomponents. Next slide, please. But to just go over in general, what are we? So the URI, like Rome, was not built in one day, and there's actually a long development cycle at this point. It started like almost Melissa, like pre-COVID, beginning of COVID. During the time, way before my time at NYC. And so you went through this 1.0, 1.1, 2.0 iteration to where we're at today, like at 2.1. And this cycle we sort of focuses on like the and we're going to keep updating it. So the goal is to go to 3.0, where we will both bring in more hazards into the tool and also potentially improve the methodology. Next slide, please. And I want to show you quickly where the status quo is with the tool. So the color scheme is trying to help you to see the sort of large component of this. Sorry, the text is really small, so you can't read it. But they're basically like a data management portion at the very beginning, data downloading and raw inputs. That's the blue. And there's in the middle is processing and modeling to calculate risk, social vulnerability, or grazing capacity and hazard impacts. That's the processing. And there's also a little bit of post-processing at the end, where it's output to the output files, the geodatabase that go onto the platform that we host in S3. And in the middle, you're right, that's the last piece. Like there is output, but the output is also additionally processed to integrate with the platform. And all of these components are open source. Next slide, please. So I want to sort of highlight what the 2.1 improvement is. Again, we work with a vendor, Arcadis, to do this. And they really went into the tool and did a great job of mapping out the landscape, so to speak. It is really complex. So what is highlighted here is like the 1.0 had 17.7 gigabytes of raw data. I been around a few different city shops, and 17.7 is pretty big in terms of come to city data products of raw data. So they map that out and really look at each pieces and like what we need. We need this. Is this really used? Is it really effective? And they cut it down to 6.5 gigabytes, which is still good, right? Like over 50% reduction if my math is correct, but but still a large data set. And also like they look at the scripts, where it is like before loss calculation, 20 scripts and 23 resilient capacity scripts. They cut it down to 15 and 18, which is better. but that's the piece I sort of want to get into a little bit. And next slide, please. And also a little bit, they sort of consolidated script, refactor it to pull some params, utility files, sort of package those a little better so you can call those more effectively around the software that we are building. Next slide, please. But like still, like the challenge, like picture that, like, right? We have 6 hazards. We are calculating all of those different factors for different hazards. Each one of them have almost like a different methodology, right? And that's why like currently like there's 15 ESL like estimate loss hazard calculation files for 6 hazards. For example, there's 3 for coastal storm flooding, which I will use the example as I continue to do this exercise. But like to picture that, like with conservative estimate, like you'll be over 20 files to manage. In the next iteration, we will add maybe like 2 more hazards to this portfolio. So, right, like just look at that. That's cut off. That's not the entire file directory for the product, and that's just in the pre-processing part of this. Next slide, please. And right, like to do a case study here, the storm, coastal storm flooding calculation. So this is a dislocation loss. This is a hazards loss calculation left on the right. I was gonna set up this as a pop quiz, but bear with me. But like you definitely can see like the difference. But they're pretty similar, I promise you. Like I did a little trick here, like I hide 3 constant declaration here, but otherwise it's 40 lines of identical code for those 2 scripts. Next slide, please. So like operationally speaking, it's just like a challenge, right? Like first of all, like each time you run a calculation for a single hazard, 3 scripts are running from beginning to end. And also like it's commented throughout pretty thoroughly by our vendor, but like you still need to get into like, it's not a super long script, so like 70, 80 lines per script, but like you still have to read through most of the things to figure out, oh, this is like doing this. This is doing the calculation now, and I'm doing output exporting here, right? Like that's from the management standpoint, just pose like, I think anyone probably can sympathize here. We're all like data professional doing this kind of work. Like that's really challenging. So next slide, please. So yeah, so most, like I'm sort of Python enthusiast, so like my go-to tool is Python. So like also like this tool is built in Python. So like the most natural thing, I think the Pythonic thing to do is like think about the first level abstraction that we can do here, right? Like what if we have a class object for just like each hazards, right? We have 6 hazards, 6 different loss calculation. Let's just set up 6 class to handle that. And it would be, next slide, please. And this is getting into it, but like at the beginning, first like initialization, instead of doing 3 different, have the those constant declare in 3 different scripts, and we just centralize it at the very beginning when we start the loss calculation, declare this also as a class variable constant, eliminate the redundancy, and much more easy to manage. And also like possible case of loss object to be initialized with different constant. Like one use case I already see this is like there's a reference year calculation. I think that's translate the dollar amount to that specific target year. Like we can set that to a 2 different year with 2 class object and just compare them very easily with that. And otherwise that would not be possible if we just have 3 scripts doing the calculation. You basically change like 3 constant and you run it, right? Like it's become very hard to manage, but with this methodology, then you have the 3 different, you can just have 2 class objects. Next slide, please. And then this is a repetition, right? This is low data and combined flood data set. That's the 2 scripts doing the exact same thing over twice. And once you centralize this, you also realize, okay, so now each runtime is cut down by, you are not cleaning and start from loading the data step, right? Like you always have that data set per se. Obviously, there's some downside with that too, right? Like you can forget that you have this class object already with data initialized, but you sort of initialize for you, and you can just do a bunch of things afterward, next slide, please. And you can do the actual calculation just from that based on the object. So now with this consolidated, you can also huge readability improvement, right? So now each loss calculation you see is actually just like 10 lines. And you realize like after I did this, I was reflecting, I realized like, oh, the calculation actually is not super complicated. It's a pretty simple after you get the flood data. It's just a simple couple steps of calculation where you get your final hazard impact scores. And without doing this, like it would be very hard to figure out like the methodology change. Like if you have a methodology change in the loss calculation, you would need to go to multiple scripts and change in multiple places just to do that. Also, and another perk maybe like you can initialize a new method, like just call it new dislocation loss method, right? And then you can do the same loss calculation. You can compare the results. Maybe like you want to see how the new calculation results are different from the last one based on the same source data, same raw data. You can just very easily do that now with this like more objective oriented approach. Next slide, please. So in short conclusion, I usually don't like this type of thinking. Like you just cut down number of lines, but it is quite a bit shorter. So like I post that here, like to 120 lines, so about a 41% reduction in how many lines of code it is. But most important is like readability and maintainability improvements for like when you have a really complicated tool. And extendability in the future, right? Like we have 6 objects instead of 15 scripts, and that just dramatically reduce as you keep adding more things. Like that's not even, that's more manageable to manage 10 like class object in the future instead of like 20 scripts. And also like maybe a superclass in place, right? Like if there's a common theme from all the hazard loss class variables, we can abstract that again to get a superclass that can have all the nice properties from that. Next slide, please. And after saying all that, thank you for bearing with me to go through that exercise. Hopefully that's somewhat interesting. But we open source everything on GitHub very recently. And the goal here is to really open up to the community, and we welcome you to take different parts of this, and also like give us your insights on how you think risk calculation might be done. I think some of this is like really, really interesting, and we even welcome your input. Make us a pull request, and we'll review it and see. Maybe you'll help us write a superclass for the hazard loss. Yeah, and next slide, please. Yeah, finally, this is our info. Again, gonna leave probably a lot of time for Q&A, but this is our presentation on URI. Thank you. Oh, question. Yeah.
So the code that's on GitHub, I imagine we wouldn't actually be able to calculate a URI with it, right? Because we don't have the data to import.
That's right.
So how would you recommend we use that? The code?
That's a good question. We also think quite a lot about that. Yeah, thank you for that question. I think, yeah, definitely like one challenge is like some of this data, a lot of it is open data. So, but unfortunately, like some of it is just like from our agency partner with confidentiality. Like we just cannot like immediately share the data with you. But we sort of welcome you to like talk to us, like if you want to do your own calculation. And also like the goal, again, like there's like publishing the methodology, we're hoping like there's like an educational piece of this, sort of like if you understand how risk is assessed and how different component of assessing risk, you understand better how your risk is calculated. And maybe you would come back to us like, hey, I don't think that really makes sense. Like, I don't see my risk to this hazard should be laid out this way. Like, maybe there's some, that kind of insight we're also expecting. Again, that would be like, yeah, like to maybe like more emergency manager sort of experts, but also like, I think like what we try to make is so that even average citizen of the city can sort of share their insight with us. Yeah, in terms of that.
This is really interesting. So I was working last year on developing a residency planning dashboard for MPO in Ohio, and we were really struggling. So we were working with the NRI data, and once we zoomed in and we started looking at the EAL calculations at the county level, it like really breaks down, right? Because it's like national level data, and then once you look at it at that granular level, it doesn't much make like sense at that point. I mean, it's a good like overview, but like it doesn't say a lot about like local risk. And so is this methodology like usable in other contexts as well? Like how specific is it to like the New York context? And just kind of throwing in one more thing there. So we were talking with like a residency planning risk analysis like research organization in parallel too. And I think what we struggled with is like they also had a set of scripts, but the processing of the raw data to feed into those scripts is also really complicated. So is there a lot of that you're also doing? So yeah, both of those questions.
Yeah, thank you for that question. Maybe I will tap into Melissa in a second here about that. But I think the goal is really, like exactly, I think that would be a terrific use case for this, is to open source the methodology and how exactly we do things, so that other municipality, I think like then your state talk to us about want to do their own version of this.
We've been in conversations with state dishes, or Division of Homeland Security Emergency Services. And they were interested in learning more about how we developed it, and but we're still sort of exploring a potential partnership, but nothing firmed up. But I mean, go ahead. Keep going.
No, I was just saying, like, so I think it's highly localized to NYC. I don't think you can just take this exactly, apply to Ohio probably, but I think the hope is that there will be some sort of lessons or things you can sort of incorporate into your own methodology. And but to your second question, also like data management, I think it's the biggest challenge with this. We're still in the process of figuring out how to set it up with this, and also going towards a cloud-based solution. Just because of the number of this, I think that's where I see a big opportunity. Just because the number of data, versions of data we have to maintain. Really doesn't make much more sense to stay in a local sort of a development environment. If we can move toward a cloud base and sort of open source technology learn well into that, there's no reason Python couldn't do that. And you just pay a more cloud-based solution, that would be, I think, more ideal for this kind of tool. Yeah.
I mean, I guess to the point of how do you replicate it somewhere else, I think it's all depends on that municipality and how much data they collect. We're very lucky in New York City that we were able to take Pluto. I don't know if you guys are familiar with Pluto data, but building, block lot, land use, Department of Finance data for like property worth, and then sort of apply it to some of our loss estimation modeling. But maybe I think Tut was kind of getting to this point, but like using the same framework and depending on what local data you have, sort of replicating the process.
Oh, question. Oh, yeah. Either is fine. Yeah.
Thank you. I'm curious to know if there's any examples of data that you wish was there, but you couldn't add it, either because the government is not collecting properly or nobody's doing the collection of that data, and it would be meaningful for the result.
That's a great question. I cannot think of one on the top of my head. But no, that's a really interesting question. In terms of hazard. Maybe Melissa will actually better.
I would say infrastructure was probably the hardest part, because as you saw in the estimated losses, it's a people, building, and tree damage. But infrastructure was like a harder thing to get, like impacts to infrastructure. I think Tub mentioned we use HAZIS, which is like a FEMA software for doing modeling, but a lot of the modeling that comes out is like building damage and less on sort of like damage to bridges and roadways and that sort of thing.
Thank you.
Do we still have a? Okay.
Hi. First of all, thank you so much. The presentation was really comprehensive and really appreciate the time. I just have a question about regarding posting your code to GitHub. Was that on the administrative side? Was it really hard to get that published? Was it difficult to like navigate internally? Was like administratively, were there other like parts of the agency that didn't want to share as much, or like how? Because I work for a different city agency, and I would love if we could share more on GitHub, but we can't yet. So I would love to hear more about how you navigate that challenge. Thank you.
I think I think for on this point, I think it really needs to credit was like way before I got there, like their whole mindset, and Ahmed, my manager, who's gonna be here today, like they built it as sort of open source, like in mind, like that whole because like the whole methodology was built on the premise that one day we'll publish all of this. So I think that really helps. And when I'm speaking to like the challenge of making it public, it's not really like about the sort of internal like approval process. It's more about like just how complicated the tool is, and we're worried that we're releasing something that no one will look at it and be able to understand it, and maybe have a lot of questions that it's not what we expected. We're just trying to hedge against that like a little bit, like try to our best ability to understand a average user, how they would see the tool and what kind of question they will have, and just make that really like we spend a lot of time on that README in that repo. So like that's really part of this that we focus on. I don't want to.
Yeah, we had a lot of like brainstorming sessions with like other city partners to kind of get a sense of anything we make public, like what level of geography do we want to show? Do we want to show like census tract? Do we want to show like neighborhood tabulation, community district? And I think because it was going public, and because also as you zoom into a smaller geography, the results are not as nearly as accurate. So we kind of came up with sort of a compromise for like neighborhood tabulation area, so that it's like you're not showing like extreme hyper local risk, but at least enough that it's meaningful.
Thank you. Really enjoyed it. I wanted to ask about the risk calculation. I think, would it be possible to go back to the slide that was on impacts?
Oh, yeah.
For the risk? Yeah.
It's right here.
Okay.
Is that this more general?
Yeah, okay. So the potential economic impacts, right? So just from my understanding, like this is all based on the economic impacts. I think I was trying to take notes. It was measured in dollars, the impacts. Are there any other forms of measurement of impacts that you work with? I know that it's probably easiest to standardize via dollars, but just trying to broaden the scope of like what can be seen as an impact.
Yeah, I think that's again like when setting out the methodology. No, that's a really good question. Like that, I think it's an effort to standardize everything. So it's actually if you look at the margin losses. Sorry, again, it's pretty small, but like there is a mortality, there is dislocation, like transportation disruption. Those are not really just like a dollars amount, but we actually have to come up with methodology to translate everything into a dollar amount, so that we can like standardize across different, and also like really combining those risks into one score for a hazard, right? Like because you can imagine like all of this for a single hazard, it's really multiple of causes are associated with it. There could be potential life losses, but also like power outage, lost wages. Those are all different things, but we want to be able to combine them into one thing as the index. So that's really why we do this kind of translation here. But I don't think we support other measures other than the dollars so far. Yeah.
Thanks so much for the presentation. I know you mentioned, I believe you mentioned at some point that you're looking to expand the data sources you're using, and I wasn't sure if it was across all of the domains or just around hazard impacts, but I know one really good data set for maybe social vulnerability is the Area Deprivation Index, which we use in health research. But then that evokes another point, and I guess a second question I have for you is, how do you balance how many data sets to use? Because obviously there's so many, and you have to assess their quality, assess their longevity, assess the funding, assess that availability, and some can be out of date for 5 to 10 years. So how do you kind of balance those challenges? And then when you're getting the public's help with the GitHub, can we also suggest other data sets that you might consider for your project?
Yeah, thank you. Yeah, did you mind repeat that? That's the
Area Deprivation Index.
Deprivation
Yeah,
Index,
from
well.
Wisconsin. Yeah, it's the Atlas project. So you can get it on the census tract level and the zip code level. I'm sort of newer to New York, so I'm not sure where the NTAs track to, but you can get that granularity, which also balances if you want a zip code level look. So it's not so granular.
Yeah, thank you. Well, we'll definitely look into that. Because
Yeah, it compares nationally, so you get it gives like percentage decile percentage comparisons in terms of what's the most deprived areas nationally, but then it also does it on the state level. So you can have it built around New York State, and so it's a little bit more localized instead of just an aggregate comparison across the country.
Oh, cool. Very interesting. Yeah, thank you. No, really appreciate that. That's kind of an input that we really appreciate. And yeah, and to your point, that's really our main job, to be able to assess what can we bring in and make sure the quality of those things are what we're looking for. Yeah, I think that's what I consider primarily my work, and that should be able to do that, and in general make our index sort of better. And we also also try to align, we also do a lot of alignment. For example, for the heat vulnerability index that DOHMH, that's a health department here in the city, they publish, we don't want to come up with a number that's very different from their risk. And I think someone earlier in Open Data we said mentioned this thing that was really enlightening to me. That was they were you have one watch, you know what time is it. If I had two watch, you don't know what time is it,
Yeah.
right? And there's a lot of risk index floating around, and we definitely would have to do a good job of making sure we're not making the public more confused about risk instead of making them more informed about risk. Yeah.
Appreciate it. Thank you.
Yes.
I know there's a lot of data out there, but I will focus just on the open data available. Have you used air pollution quality 3 levels in the city to see the impact of heat wave on the society? So I was wondering.
Yeah, cool. Great question. I don't think I have the slide here. We actually do have the hazard breakdown, each hazard, what's the losses calculation is. You said air pollution on heat.
Yeah, air
impact?
pollution. Because I know there's a lot of fires from Canada, which is affecting here too.
Oh, right. the air quality
You also
index.
have
Yeah.
3 levels in the cities, because there's a couple calculations that where areas that don't have trees usually have 5 Fahrenheit or difference in degree of heat. And then I think in New York City, 350 people already died from a high heat wave. And areas where you don't have those 3 available, usually heat will be higher than the other ones.
Tree canopy coverage is considered for our calculation. So yeah, that's part of the resiliency capacity calculation, I believe, right? Yeah.
Yeah, but air quality is not in this
Oh, I see.
calculation. It's a good thing, maybe something we can look into in the future. But we have, Tom mentioned another tool that we have, the hazard history tool. And each event has consequences. And we do have some air quality data for events from the health department. But it's not in the URI, but something we can consider in the future.
Yeah.
Awesome. Thank you.
Yeah. And your case is interesting, right? Canada fire is not exactly
It's
in your
not in the
city,
US, yeah.
but
But
it does
yeah,
impact
affect
us. So that's a very interesting case of look at that. Yeah. Thank you all for coming. Stay around for the last of our last presentation. Thank you.